Hello, my name is Hiemstra. I'm director of CGN, Center for Genetic Resources in the Netherlands, that is part of Wageningen University and Research. I'm also currently chairing ATF-EAAAP, the European Regional Focal Point of Animal Genetic Resources. The title and key question of my presentation is: which breeds and breeding goals are needed in the transition towards more diverse or biodiverse livestock systems? Recent assessments, in particular the assessment of the Intergovernmental Platform on Biodiversity and Ecosystem Services, show clear evidence that global biodiversity is threatened. Multiple factors play a role in biodiversity loss, including the negative impact of agriculture and livestock production systems. In 2019, the State of the World's Biodiversity for Food and Agriculture report was published by FAO. The report stressed the importance of conservation and sustainable use of biodiversity for food and agriculture. The pie chart on this slide shows the global status of farm animal genetic resources. A large proportion of all local livestock breeds is at risk of extinction. When we correct for the breeds that have an unknown status, the majority of the local breeds in Europe have the status at risk. As agreed by European countries in the FAO Global Plan of Action, more efforts are needed to conserve and to promote the sustainable use of farm animal genetic resources. The relationship between livestock systems and biodiversity is complex. First of all, livestock systems cannot function without biodiversity. For example, soil biodiversity or the livestock species and breeds used in livestock systems. Biodiversity contributes to the productivity, performance, and the resilience of livestock systems. However, while livestock systems can have a positive impact on biodiversity, for example in relation to extensive grazing systems, livestock systems have also been a driver for global biodiversity decline, either at farm level, at landscape level, or globally. There are three relevant levels of biodiversity: biodiversity at ecosystem level, the diversity at species level, and last but not least, the genetic diversity within species at breed level or DNA level. And the spatial dimension of biodiversity is also relevant. For example, farming practices can either have biodiversity impact directly on farm level, but also at landscape level or globally. A transition is needed in the livestock sector when we consider the negative side effects of the currently dominant livestock systems. Clearly, biodiversity should be taken into account when further developing livestock systems. For example, the European Wild Bird Index indicator shows that the number of common farmland birds has dropped substantially in the past decades, which can only be reversed by a transition in the further development of livestock systems. Future livestock systems should follow agroecology and circularity principles, and optimization is always context or region specific. Livestock systems provide a variety of ecosystem services. The Millennium Ecosystem Assessment identified 4 categories of ecosystem services. Provisioning services are the products obtained from ecosystems, for example, food and raw materials of various kinds. Examples of regulating services include regulation of the climate, air and water quality, or flood regulation. The social-cultural value or recreational value of livestock systems and breeds are recognized as cultural services. Supporting services or habitat services are services necessary for the production of all other ecosystem services. Examples are soil formation or pollinators. Based on this graph, we can conclude that livestock systems should be better recognized and valued for the diversity of ecosystem services that they provide, including breed-related ecosystem services. The results of a recent European Animal Genetic Resources survey showed a perceived positive relationship between livestock grazing and the range of ecosystem services. Cultural and historical ecosystem services were reported by 84% of the respondents, and also high percentages were shown for educational values, landscape values, habitat provision, nutrient cycling, and fire control. The second State of the World report on animal genetic resources of FAO in 2015 also reported about the most relevant ecosystem service-related breed characteristics. Adaptation to mountain areas, marginal and harsh production environments, and fragile soils were mentioned, and also grazing and browsing habits in relation to removing specific weeds or invasive plants. To answer the question which breeds or breeding goals could be beneficial for a diversity of future livestock systems, we can think in different scenarios. On the slide, I presented two different scenarios for dairy production systems, A and B. Scenario A is characterized by further intensification and specialization, and high input and high outputs per hectare. The aim is to maximize production efficiency per kilogram product. This scenario A is in line with land sparing principles, which implies segregation of high-intensity agricultural land that can go together with maximizing protected nature areas. In this scenario, grazing time will be restricted and the diet of the dairy cow is optimized to make full use of the animal's genetic potential. Price and added value per kilogram product is based on world market prices. Scenario B is based on land sharing principles, meaning that food production is combined and integrated with biodiversity and nature conservation on the same land. This scenario is characterized by high nature value farmland, 100% grazing, and lower input and output per hectare. In order to compensate for lower productivity per animal and per hectare, there is a need for a higher added value per kilogram product and payments for ecosystem services and biodiversity. It is obvious that breeds and breeding goals should be different for scenario A and B. When we focus, for example, on scenario B, we can raise the question which breeding goal traits are more important in nature-inclusive biodiverse systems compared to more specialized livestock systems, and also which breeds would be suitable. Farmers in nature-inclusive livestock systems are expected to put more emphasis on making best use of the available feed resources in the system, which can be of varying quality and nutritional value. In more extreme situations, animals should also be able to cope with feed scarcity or extreme climate. Resilience and robustness related traits will be prioritized. And finally, animal behavior may also become more relevant in more nature-inclusive and biodiverse livestock systems. Think about interaction with humans or adaptation to predators. This is another example of a breeding goal discussion and different perspectives on breed preferences. Wageningen and German colleagues debated the general understanding that increasing milk production per cow will contribute to lower greenhouse gas emissions and will reduce the environmental impact per kilogram of milk. Based on model calculations, the authors concluded, however, that increasing the beef output from dairy systems, for example by replacing specialized dairy breeds by dual-purpose breeds, will reduce emissions of milk and beef production together. This in contrast to producing similar amounts of milk and beef by specialized dairy systems and specialized beef production systems. This research initiated discussion in the Netherlands whether it is time for a revival of local Dutch dual-purpose dairy breeds, which have been largely replaced by Holstein Friesians in the past decades. In summary, it is relevant to maintain a broad genetic base and breed diversity, to be able to anticipate changes in livestock production systems, climate or consumer demands. More diverse or biodiverse livestock systems may give opportunities for enhanced use of breeds that are currently at risk. Specific livestock system characteristics and limitations should determine the breeding goal and make best use of the available genetic diversity within and across breeds. Secondly, livestock systems provide a range of ecosystem services. However, the values of ecosystem services provided by livestock breeds and livestock systems should be better recognized and valorized by the market, or supported by policies and public payments. Breeding programs should focus both on maintaining or improving the quality of the breed and on conservation of sufficient within-breed genetic diversity. And in addition, gene banks are an important long-term insurance and complementary strategy for conserving genetic diversity within and between breeds for future use. At European level, the aim of the European Regional Focal Point, the network of national coordinators for the conservation and sustainable use of animal genetic resources, is to exchange knowledge and experiences to better manage animal genetic resources at national and pan-European level. And through the IGENA initiative, ERFP initiated the development of a European network of gene banks for farm animal genetic resources. In this way, ERFP contributes to the conservation and sustainable use of animal genetic resources in a wide range of current and future livestock systems. Thank you for your attention.